Okay. Uh, hey class. So this is going to be a quick recording of explanation for today's slides, just because we were not able to record today's session. There is the homework assignment, of course, due next week before Wednesday, before class on Wednesday. And then there's also a quiz during next week. Since there are quite a bit of midterms during next week, we are going to cut next week's class and have the first portion going over parameters. Parameters will be next week's topic, and we're going to use the remainder of class to do the quiz. If you have problems with doing Tableau and Zoom at the same time, I would recommend for you to leave the call on your computer, maybe call in during your phone, and have your webcam on, and also have Tableau open just so you can complete the quiz. And if you do have any questions, that's where your phone comes in, so you can call ahead and ask any questions. So this week we're going to be going over quick table calculations and calculated fields. These are two different ways to manipulate some of your data. The great thing about this is that the data is stored locally. The changes are made locally to Tableau rather than your data source file. So if you're using an Excel file with your group mates, for example, for your class project, or let's say you're working in industry and you are working with a server, SQL server, whatever, you are not making any changes to the data that everyone else is using, but instead making a few changes and manipulating your data on Tableau itself locally. And so if you were to share something, if you want to share some of the work that you've been doing, you can go ahead and share your work as a .twb file. So that is your Tableau workbook. But if you save it as a .twbx, that shares your workbook and your data source. So let's say, for example, if you're working on a Makeover Monday or Workout Wednesday for a Tableau community project, you can go ahead and send the .twbx to me so that I don't have to go out and look for your data set. So now we'll be going over into the class content. So first we will start with quick table calculations. Again, primarily reiterating a lot of what I just talked about, but quick table calculations give you more information on the data that you have. You can also use quick table calculations for dimensions and measures, but they don't create new data or new information. So instead of, let's say, combining like city, state, and zip code, or having a cost, it's just aggregating or representing or visualizing the data that you have currently in a different manner. For the scope of quick table calculations, we are looking at quick table calculations in the sense of tables, panes, and cells. So a cell would be just like Excel, where you would just have approximately about one value, pretty small amount. And then if you expand, then we have pane. If you look to the highlighted area, we are looking at the region of Asia and looking at each quarter for 2014. So that's one pane. So for example, this image has 4 panes. So it has Asia for 2014, 2015, and then Europe for the same amount of time. And then you also have your table, which is the whole thing. So you have multiple cells in each pane, and you can have multiple panes in each table. Primarily within the examples that we're going to be seeing today, within the slide deck, we're just going to be looking at quick table calculations in panes, but of course you can do that in tables. This example showing the totals on each side, on the right-hand side and the bottom of that table. Those are quick table calculations. So aggregating each vertically down, showing 100%, and then also across. So in table across, table down, in the past, I found students had a bit of difficulty in understanding which was which. And so I just want you to think table across is we're doing the math horizontally. And so we are going to be looking at each region, so Asia, and its performance in each quarter. So these two tables, as well as the one in the previous slide, this is looking at, I believe, the amount of travelers in each region for a year. So let's say we're a travel agency analyst and we are looking at, for example, the table across, we're trying to determine what is the quarter that has the most people traveling in both Europe and Asia. So we want this to represent 100% because we want to know which quarter has the most people. So it is clear that in Asia, we have about 31%, which is the highest percentage. The 31% of the total travelers travel in quarter 3. In Europe, relatively the same. We are looking at 36% of travelers in Europe travel in the third quarter of the year. And so when we look at table down, we can look at it in a different manner. We might want to look into, okay, is there a difference between the amount of travelers that travel in quarter 1 and quarter 2 between the two regions? So which region has more travelers in one quarter over the other? So it looks like Europe just slightly edges out Asia on each of the 4 quarters. And let's say if we had to propose a specific time for when we should higher or lower prices, maybe we can make the recommendation that in quarter 3, we can raise Europe's prices because more people are more inclined to travel in Europe during the third quarter. So we see 35 and 65 adding up to 100%. Another example, just off the tip of my tongue, if we wanted to maybe raise prices, or sorry, lower prices to encourage more people to travel, maybe quarter two, or maybe even quarter 1, not a lot of people are traveling. Maybe in Asia, we would want to reduce prices for flights or add some kind of bonus with our different partnering corporations to, have people travel more in Asia during quarter 2, and maybe we can do the same for Europe in quarter 4, since there's relatively low performance. So just to reiterate, on a very high level, table across is looking at calculations across, the table down is looking vertically, so top to down. So for calculated fields, this is going to be where you get to create new fields and manipulate your data in a certain way and create essentially new dimensions and measures. So I do want to reiterate, for table across and table down, you are not creating new data. You're changing the way it is being represented or visualized within your sheet. And so with calculated fields, you get to create new dimensions or measures. So on a high level, well, actually not on a high level, just to get started, calculated fields help you customize your data. You get to manually create your dimensions or measures, and it does not affect the original data source. So OG, original data source, it doesn't affect that. It's all local. I do want to show here, these are the different things or the different colors which represent different actions in the calculated field. So the orange are going to be fields, or your dimensions and measures. Your blue is going to be functions. So I believe last class we were talking about averages, sums of discounts, and so that is a function. Operators are going to be really PEMDAS, so if you wanted to use a parentheses or brackets, you can use your operators. Parameters, that's going to be discussing in next class, but it will be showed in purple. And with comments, they will be shown in green. And so in class, I did mention that if you had some experience with Python or SQL, you might just be in the habit, or things might come more naturally. Just for example, for some APIs and whatnot, whenever you code, you can sometimes use double slash for making a comment. So in order to make a comment during a calculated field, you have a double slash. And so in this example, we're looking at the sum of GDP and the sum of population divided against one another. So in doing calculations, I mentioned we can do them for measures and dimensions. And so we're going to first start off with talking about measures. So in measures, you are creating measures essentially to drill down in your data. And whenever you do these calculations, Tableau looks at them in the sense of PEMDAS. So the straightforward, normal order of operations. And you just want to make sure you're doing that appropriately. So in these two examples, there is a difference between typing in profit divided by sales and sum of profit divided by sum of sales. And so profit minus sales is quite literally dividing those two measures. So if we see over here, we have profit and sales. If you divide them, yeah, it's going to be relatively 50%. And it's doing it for each one of those and then giving you the total of all of these ratios. So the ratio of profit and sale and then summed up. Over to the right, we have our same table, except we only have the totals at the bottom. And so what the difference is for this is the sum of profit minus the sum of sales. So it's aggregating all of those and then dividing. So it's making sure we're doing the appropriate order of operations. With dimension calculations, it's a bit, well, more or less the same. We want to make sure we're still having the correct syntax. So with the order of operations, that's the appropriate syntax. But with dimensions and calculations, you want to be able to make sure that you're speaking the same language as Tableau. So Tableau will do its best to speak English or whatever language you're working in. And you have to do your best to make sure you're speaking the same language that Tableau understands. And so with dimension calculations is what I call them. You can use this to combine, in the example, city and state. So we have that down here. So what do we have to do in order to include city and state? So let's say we already have those two dimensions existing. So state could be California, and the city could be a Riverside, right? So if we want to look at this example, just ignore how it's a zip code at top. You have city and state. While this calculation is valid, what's going to end up showing up is it's going to show Riverside, California with no spaces, with no columns. It's going to appear as one word. But if we include a bit more syntax and follow along and combine Tableau's language with our common language, we can make that appear in a more common sense, or just easier to understand, something that people and ultimately your end user is more common or more used to looking at. So you have your city and state, ignore zip code again. We'll get to that soon. If you're looking at city and state, you can include your city dimension, add the plus, and then in quotes, add a comma and a space, and then end quote, put a plus, and then your state. And so now you're telling Tableau to say, okay, add the city name, and right after the last letter, so the E and Riverside, add a comma, add a space, and then say the state name. So that's where it will say California. And so it will say Riverside, comma, space, California. Easier for us to read and understand. And we were able to do that by just adding a bit more information for Tableau to help us visualize our data. And the last part of dimensions would be string and numeric strings. So this is more so going into the topic of adding a zip code, for example. We can go finish that this past slide off by adding a zip code. So Tableau can automatically recognize lettered strings and can geocode. So when we're looking at zip codes, let's say 92507, that's the zip code for Riverside. And so if we click, let's say we can double click our zip codes, it will automatically appear whichever zip codes are recognized or registered, I'm sorry, whichever zip codes are recognized will appear onto the map, and it will show every zip code that's on there. Something that we have to keep in mind is that if we want to concatenate, so combining different measures and dimensions, we have to make sure they are all the same type. So we have to make sure that numbered strings are being represented as numbered strings and not numbers. And so a common thing that Tableau will do, if it does not automatically recognize zip codes, it will start adding them. Maybe let's say we have a social security number. It will start adding and summing or averaging or taking the minimum or maximum of a social security number. And that's, in this case, doesn't really mean anything. We don't want to add up social security numbers. That makes almost no sense. So we want to make sure that we can make it into a dimension, or we are making Tableau understand and recognize that this is a string. We should not be aggregating this number. And it can, in fact, be included in, let's say, name, comma, space, social security number, or city, state, and zip code. So in this example, we're going to be looking at just that, city, state, and zip code. So we have our city, plus, comma, space, plus, state, plus, comma, space, plus, and then we have our postal code. But for some reason, we are getting an error in our postal code. And so the reason why we're running into that is because we have to make sure that Tableau recognizes that postal code. And so in this example, in this next image, we can see that postal code has a string operator attached to it. So type in str and then parentheses on each side around postal code, and it will recognize it as a string. And so now when you hit OK or apply, and you can drag that calculated field into your view, you'll start seeing the city, state, and zip as formatted in the following. You know, it would look like Riverside, comma, space, California, comma, space, zip code. So the zip code for Riverside is 92507. And yeah, that's about it. So that's all we talked about today in class. If you are interested in looking at the demos, there's a YouTube video somewhere on my YouTube channel. You can go and either look at the announcement, or you can go and look at the description. I'll go ahead and link it there. So I showed how to do the dimension and string. If you wanted to do a dimension calculation, this is, the numeric calculation. This is essentially how you would do it. Within the calculated pop-up box, you'd have to do sum profit minus sum of sales. And yeah, that's about it. So for the homework, you just have to make sure you include one example of a table across or table down. So you can go and follow that YouTube video. That's where we did the bar charts, and we were looking at the contributions of, let's say, technology to 2018, or technology to the rest of the whole year, or range of years. So you have to do one calculated field, and then you have to do one example of a calculated, you have to do one quick table calculation, which is what I just covered, and then the calculated field, which is going to be something like determining a zip code, or if you wanted to do cost, you could do profit minus sales, and that will give you your cost. And just make sure, if you were to do a numeric one, you have to make sure it is ordering the correct order of operations. So you want to make sure you export that as a .twibx file, not a .twb, because I want to see your data set, and it'll just make it easier to grade. So yeah, if you have any questions, send me an email for my students. If you, for whatever reason, are not one of my students and watching this video, you can go ahead and comment down below, and I will do my best to answer your question appropriately. So thanks, everybody, and looking forward to seeing you all next Wednesday.